Let's continue looking at section 5.3. So today's objectives, we're going to identify the pairs of angles formed by transversal cutting parallel lines, and we're going to apply theorems about parallel lines. So let's take a look at this diagram. There's a whole bunch of stuff going on, but there's two different problems that I want us to look at with this picture. So notice that we've got lines A, B, and C. They are the vertical lines. We've got X and Y. Those are the horizontal lines. And there looks like there are 24 angles in this picture. So in the first problem, it says if the line A is parallel to the line B. So I'm going to highlight it. So A is parallel to B. So remember, parallel means that they're never going to intersect. We are given that angle 15, which is this angle right here, is a 73-degree angle. And they're wanting us to know, well, what's the relationship with angle 14? So it is going to be important that we understand what transversal is taking place. With 14 and 15, notice that it is this line Y that is helping form both of those angles. So the three lines that I have highlighted, those are the two parallel lines and the transversal cutting it. So notice that 14 and 15, they are both above the transversal. So they're on the same side and they're both inside of the parallel lines. So that makes them interior angles on the same side. And so remember, interior angles on the same side are supplementary. So if I'm giving you a 73-degree angle, I need to subtract 73 from 180 to get the measure of angle 14. So 180 minus 73 gives me 107 degrees. And so then it asks us to justify, why do I know that? So like we said, we start with parallel lines because that's what was given, if A is parallel to B. And then what we were dealing with in this picture, 14 and 15, are same side interior angles. That means they are supplementary. And there's my justification. So it's using the theorems that we talked about yesterday. So now I'm going to erase these highlights so then I can focus on the second part. In this second problem, it says that X and Y are parallel. So X and Y are the two lines that will not intersect. We're talking about angle 3. Angle 3 is right here. They're saying that that is 102. And then we are looking at angle 21, which is over here. So while the two lines that are parallel have three different transversals, based off of the angles that we're focusing on, we want to focus on the transversal that helps form those angles. So it looks like line B. So if 3 and 21 are dealing with the transversal of B, notice that they are on opposite sides. 3 is to the left of B and 21 is to the right. So they are alternating. Because those are both outside of the parallel lines, that means that we are dealing with exterior angles. So we have alternate exterior angles. That means that they are congruent. So if angle 3 is 102 degrees, so is angle 21. And so, like we said, to justify that, we were given parallel lines. So that has to go first. And then what we know is that we had alternate exterior angles. And so that means that they are congruent. Okay, so we're justifying our reasons with those theorems that we talked about yesterday. All right, let's go ahead and take a look at some algebra problems. It says find the measure of the angle indicated in bold. I know it's a little bit hard to see, but like this is the bolded angle for the first problem, and this is the bolded angle for the second. Okay, but notice that in part A, I have the arrows that indicates that I have parallel lines. So the transversal is intersecting parallel lines. The two angles that are given, they are both inside the parallel lines and they're on opposite sides of the transversal. So thinking about it, if I know that I have parallel lines, these are alternate interior angles. And so remember, alternate interior angles are congruent when we have parallel lines. So I get to set those two equal to each other. So 27x minus 5 is going to equal 26x. So I'm going to move the 27x over to the other side to get the x's together. That gives me negative 5 to equal negative x. I'm going to divide both sides by negative 1. So 5 equals x. But that's not my final answer. I have to plug that into my bolded angle. So I want 27 times 5 minus 5. Well, 27 times 5 is going to give us 135. So when I subtract 5, that gives me a 30-degree angle. In problem B, notice that my arrows indicate that I have parallel lines. With the transversal, the two expressions that I have are on the same side. But one of them is exterior and one of them is interior. So when I have parallel lines and I essentially now have corresponding angles, remember, with parallel lines and corresponding angles, that means that they are congruent. So I'm setting up another equation where two things equal one another. I'm going to subtract the 10x to get the x's together. That gives me 2x minus 2 to equal 20. I'm going to add 2 to both sides. That gives me 2x to be 22. So I'll divide both sides by 2, and I get x to be 11. Now that's not my final answer because I want the measure of the angle that's bolded. I circled that for us. So I want the measure 12 times x minus 2. So we want 12 times 11 minus 2. Well, 12 times 11 is 132. When I subtract 2, looks like I got two answers that are both the same. That's not always going to be the case, but that's another 130-degree angle. All right, here's my next one. It says if P is parallel to Q. So even though it's not marked in my picture, I'm giving you that information so we can mark it in the picture. Those two are parallel. They will never intersect. That means R is the transversal. What we want to find is X, Y, and the measure of angle 1. All right, so it looks like these expressions have both X's and Y's. So we could have a system on our hands. So excuse me. If I look at the relationships of angles, one of the relationships I see are these two expressions right here. Notice that those two angles share a vertex and they're directly across from each other. So that doesn't have anything to do with parallel lines. Those are just vertical angles. And so something that we've learned all the way back at the beginning of the semester, vertical angles are congruent. Congruent means equals. I get to set those two equal. All right, what's another relationship that I see? Well, I see that this angle of x plus y and this angle of 2x plus 2, they are on the same side of the transversal. I see that they are both exterior angles. Well, when you have exterior angles on the same side, that makes them supplementary. Supplementary means that they add up to 180. So there's my second equation. 2x plus 2 plus y plus 7 equals 180. So now that I have that, I'm going to set it up where I can maybe do elimination. So that means if I want to do elimination, I'm going to move the y over to the other side, and I got to get my like terms with the numbers, so I'm going to subtract the 2. Down here, all I need to do is move the 2 over to the other side as well as the 7. All right, so that means my new top equation is going to say 2x minus 3y, and that's going to equal negative 19. If I look at the bottom, we'll have 2x plus y, and that's going to equal, what are we subtracting? We're really subtracting 9, so 171. All right, so with elimination, I need to have something add up and cancel out. Right now, nothing's going to cancel out. 2 plus 2 won't turn to 0. Negative 3 plus 1 is not going to turn to 0. So a couple different avenues that we could take. One of them is we can eliminate the x's or we can eliminate the y's. And it really doesn't matter in this case because the x's are the same number. So that means I just need to change one of them to a negative. Or with the y's, because there's technically a 1 in front of this, I can very easily turn that to the opposite of negative 3. So because it's saying to solve for x, y, and angle 1, I'm going to solve for x first. So that means I want to get rid of the y. So I have to multiply the bottom equation by positive 3 because if the top y is negative 3, I need the bottom equation to be negative 3 with the y. Or sorry, positive 3 with the y. So that leaves me with 2x minus 3y equals negative 19 on the top. And now when I multiply the 3 to the bottom, we'll have 6x plus 3y. And then 171 times 3 gives us 513. So now when I add these, the y's are going to cancel. 2x and 6x add up to 8x. 513 and then minus 19 is going to give me 494. And then I'm going to divide both sides by 8. And it looks like I'm going to get 61.75. So it's okay that it's a decimal. That's my x value. That's one of the things that I wanted. Okay, now I need to solve for y. So there's quite a few different equations. I think I'm going to go back to the equation that I had prior to multiplying the bottom by 3. So I'm going to have 2x, but now I know that x is 61.75 plus y, and that equals 171. Well, when I multiply 61.75 by 2, I'm going to get 123.5 plus y equals 171. I'm going to move that 123.5 to the other side by subtracting, and that gets me the y by itself. 171 minus 123.5 gives us negative 47. No, it doesn't. It gives me positive 47.5. All right, so there is my y. So we have 2 of our answers. The next thing we want is the measure of angle 1. Couple different things that we can think of here. So I have a relationship between angle 1 and this angle of 3x minus 17. Because I have parallel lines, those are alternate interior angles, which means that they are congruent. So I could definitely do that. Or I have a relationship of angle 1 and 2x plus 2. Those are corresponding angles. Corresponding angles are congruent. So that's another route I could take. Or we have y plus 7 and we have 1 and they're right next to each other. They are forming a straight angle. They are supplementary. I could set up an equation where I add them up and set it equal to 180. So I actually have 3 different ways to solve for angle 1. Probably one of the easiest would be to set 2 things equal to each other rather than the supplement. So I think I'm going to do what I highlighted in yellow. I'm going to find the measure of angle 1 by just substituting the value of y into the 3y minus 17. All right, so 3 gets multiplied by 47.5. That gives us 142.5 minus 17. And so it looks like the measure of angle 1 is 125.5 degrees. Okay, so that has us identifying pairs of angles formed by transversal cutting parallel lines and applying theorems about parallel lines.